In this recording, we're going to learn how to solve systems of linear equations using the graphing calculator. So hopefully you've got a graphing calculator available. And it turns out it's a pretty handy way to solve any type of system. In fact, any type of equation that we may not be equipped to solve algebraically, as long as we're okay getting an approximate answer in some cases. So this first situation is one we're going to have to set up the system. Okay, so part A, it says write the system. Then we're going to sketch and label this graph to solve it. Okay, so let's go through. I'll have you pause after you've underlined any of the important facts in here. Play the recording when you're ready. Okay, so hopefully you identified the base rate, meaning what they're going to charge no matter what for any call, and then 20 cents per minute. That means that is dependent on the number of minutes you speak. Whereas, so let's write that equation. So we'll call it y, and we'll call this just the A company. So they're going to charge $1.50 no matter what, and then 20 cents per minute. So per means every minute, right? So that means it has to do with the x. So let's define let x equal the number of minutes, and let y equal cost of call. Okay, so we always want to identify these factors. So $1.50 just can happen once, 20 cents every every minute. Now keep in mind the 20, we can't just write it like this, 20x plus 150, because what that would really mean is $20, right? Because the 1 is measured in dollars. So we actually have to write it like this, 0.2 x plus 150. I want you to do something similar with the B company. Play the recording when you've written your equation. Okay, so hopefully you identified something like 35 per minute, no base rate. So 35 cents every minute plus 0, right? They don't charge anything just to get the call made. So now we need to set up this set of equations. Okay, so we're going to try to graph these equations, but we're going to do it in the calculator. So grab our calculator, and we're going to go into the y equals. So clear out whatever's there. Our first equation said 0.2 x plus $1.50. While our second equation was just 0.35 x with no $1.50. So we're going to want to see a graph of this. Now, the grid they gave us is like a big grid that shows all four quadrants, but that's kind of absurd, right? Because if this is the y and this is the x, we just defined our variables x and y. We said x is number of minutes. Well, there wouldn't be any negative minutes, right? And y is cost of call. There wouldn't be any negative costs. So everything that we're going to consider has got to be here in quadrant 1. So when we set up our window, we're going to want to make sure we're just pretty much looking at quadrant 1. And I'm not sure, frankly, how far out we need to go. Let's check out our table. So hit second and then table. Again, ignore any negative time. Let's get into some positive numbers so we can kind of see what's happening here. The company A's are in blue here. They're going up by, what, 20 cents. And the company B's are going up by 35 cents. So, see when they start to pass each other. Well, it looks like they start to pass each other around 10 minutes. So, we don't need to go much beyond 15 minutes. And we don't need to go much in the y direction beyond like $4 or $5, right? So let's set up our x to go from 0 to 15 and our y's to go from 0 to 5. See if that looks good. Again, it's a work in progress. So our x is going to go from 0 to 15. Again, what I pressed was this window button to get to the screen. For X scale, you can leave it just as 1. Remember, we had defined over here that X was the number of minutes. So you can leave a tick mark. That's what the scale means, every 1 minute, right? We said the Y's, according to our table, we could go just from, let's back that up, 0 to 5, we said. Okay, again, that's dollars. Again, 1 mark every dollar would be fine. Now we can press graph. Company A, company B. Okay. So let's come over here and say what our scale was. Again, we got our scale. We got a sense of our scale from our table. So the X's, we went from 0 to 15, marking it every 1. Our Y's, we went from 0 to 5, marking it every 1. So therefore, I'm just going to, because I can't see my screen and my writing area, let me just take a little screen capture real quick, place that over here. Okay, so for reference, as I'm making the graph over here, we're going to start up the y-axis approximately here, and the other one's something like that. Okay, so that approximates what I've got here on the graphing calculator. And again, I just need to indicate here that, okay, this was 5 and this was 15. That indicates my scale on my graph. Okay. So, next question. How much money would company A charge if you talk 7 minutes? Well, let's think about what that means. Was 7 the X or the Y? Okay, so you go up and you say, okay, well, minutes was represented by the X, right? So if we go back to our calculator, and the first equation we entered was A. So let's shoot back to our calculator. We look at our table, second, and graph. When X is 7, the Y, Y1, shows the amount of money company A costs for 7 minutes. So $2.9. Or as we say, $2.90. If you talk for half an hour, what company would be cheaper? Just looking at the graph, you should be able to figure that out, right? This is company A, blue. This is company B, red. And we're only seeing 15 minutes. If we were to go out to 30 minutes, which would be out here, which do you think would be the less amount of money? Play the recording when you've thought about it. So hopefully you thought about it and you realized company A is growing at a slower rate, right? They're only growing at 20 cents every minute. So they're not going to ever increase faster than company B once company B's already passed it at this point here, at this point of intersection. So clearly it's got to be company B or company A. But we could confirm that if you have some skeptics among you. Now you can scroll down. And clearly we can see that at 30 minutes, Y1, which represents company A, is less. As we had predicted, right? All right. How much money would you save? Well, it's a good thing we have the calculator because we wouldn't have found that out just by kind of extrapolating, which means continuing the graph out beyond what we can see. We wouldn't have had the specific amount. So now you can look at these and pause and think for a second. How much money would you save after 30 minutes if you went with company A? Okay, so hopefully you realized it would be $3, right? It's 10.5 minus 7.5 is $3. And finally, how many minutes would you have been talking if your bill is the same? So I'll leave that up to you. Look at your table and see if you can see where the phone bill, the Y's, are the same. Play the recording when you're ready. Okay, so I can see that at 10 minutes, the Y's are exactly the same. They're $3.50. Now, let's say it didn't show up exactly on the table, because sometimes that's the case, right? Where it's going to show you that like a little below 10, one is better, and a little above 10, the other's better. We can't tell exactly what the amount of time is. So here's a tool you can use in your graphing calculator. It's very handy. So let's press graph. I want to find the intersection of those lines. Now I can kind of eyeball it, right? I can see it's about there, which looks like it's about 10, but I can't tell exactly, maybe just by looking at it. So here's a technique that always works. You're going to hit second and then the trace button. We want to use choice 5, intersect, right? Okay, so it's going to ask me a series of 3 questions. It's going to say first curve, because keep in mind, you could have put in up to 10 different equations in your y equals. It doesn't know which 2 you're talking about, which 2 you want to find the intersection of. So up top it says y1 equals this. Yes, that is my first curve. So just hit enter. Now it's going to ask me a second question. Second curve. Is that your second curve? Yes, it is. Hit enter. And now it says guess. Well, 2 lines can only cross in one place, but we've studied some other functions, right? Like parabolas, that maybe a line and a parabola could cross in more than one place. So it needs to know which intersection point you're speaking about. So just use your cursor to move your cursor somewhere close to this intersection point using the right or left buttons. Now that it's reasonably close, hit enter. And at the bottom, it shows the intersection. And doesn't that agree with what we had said it would, right? Intersection at 10 minutes is going to cost $3.50. Thanks for watching.